Did I tell you about the plastic bottle thing?
No.
Mark Lynch bought a bunch of plastic car models in Malala at a hobby shop.
Yeah.
And he has these students making them, following instructions, assembling something. I bounced off to Suzanne yesterday. She loved it. And Alan thinks he's got CTE money for it.
Oh, cool.
So they're
nice.
10 to 20 or $25 models. I told Alan, I said, hey, $400 ought to do it for the 18 students in the advanced class.
Yeah.
Take care.
Nice. We'll see you. Good morning.
Morning, Mr. Fitzgerald.
Hi, Caitlin.
I do have a question about 5-2.
Okay. We'll go over that here in just 1 second. Let me get attendance and everything going here.
Okay, thank you.
Good morning, William. Well, good morning, everybody. How's everyone today?
I'm
I'm pretty good.
Good, good.
Just a little bit tired.
Yeah, I'm with you there.
Yeah.
8 o'clock is way too early to start school. We should start it.
Yeah. Oh yeah. I'd much rather just go to school.
I found that as I've gotten older, I'm up earlier, but that just means I go to bed earlier.
Yeah, I've been going to bed way earlier, especially trying to fix my sleep schedule from
Yeah.
staying up late to going to bed at like 10:30.
Yeah.
Yeah.
Yeah, when I was in high school and college, man, I could sleep 12 hours, no problem. But
Mhm.
I'm older now. Getting 8 hours of sleep is a big deal. All right, we got a couple more people coming in.
Can I ask my question now?
Yeah, go ahead, Seth.
Okay. So for number 14 on 5-2,
Okay.
I don't know what it's asking really.
Ah, yeah, yeah. So let me share my screen here.
So it gives me an equation. Tells
Yeah,
me
it says where can't that happen, right?
yeah.
Okay.
It says yeah, what is the only value of x not in the domain?
Yeah. So if you think about the domain, right? So the domain is all the x values. So we're talking about the x values. So we're looking for anything where the x value would cause, an error, or it couldn't be calculated, or it wouldn't exist, or something like that. Okay. So probably the best way to kind of look at that is I'm going to look at a graph and a table of values, and so we can kind of see what's going on there. So we got f of x equals 1 over 2x plus 8. So let's go to Desmos.
Can we do
And so we got f of x is equal to 1 over, what is it, 2x plus 8, 2x plus 8. Okay.
well mine is different, but okay.
What's yours?
Mine is 4x plus 2, but
4x plus 2. Okay, same sort of concept, but let's take a look at that. All right.
All right. Sorry.
Okay. So if you look at that graph, right, that's kind of a funky looking graph.
Yeah.
You see it's got that split right there in it. Okay.
Yeah.
So that's kind of where we're looking at, right? That's where that graph kind of falls apart and has some issues. So what we're trying to do is we're trying to figure out, like, where is that exactly? And so probably the best way to do that is to look at a table of values. And so so I'm going to take this and turn it into a table of values. And so I'm going to go up here to edit list. Oops, I'm going to go up here to the little gear, and I'm going to say make that a table of values. Okay. And I'm going to look to see where that kind of falls apart. And it looks like, if I look on my graph here, so this is -1. So this is like a half, maybe like around a half or something like that. So -1/2. So I'm going to look here and say -1/2.
Okay.
And when I put that in, you see what happens there?
Undefined.
Undefined. Now, why would that be? Why is that undefined when x is -1/2?
Because it's a fraction.
Not necessarily, right? If I put in 1/2, right, it gives me a value. If I put in like -1/4, right, it gives me a value. So why is that particular value an issue?
Hold on. I'm not quite sure.
Okay, so let's think about this. What do we know that's undefined, right? So when we talk about numbers, what kind of numbers are not defined?
When they're undefined, it usually means they probably don't exist. Or
They don't exist. Yep. Can you think of a number that's undefined?
The imaginary numbers.
Okay. So if I took a square root of a negative number, right? So that's not one. And then there's one other one.
The ones that are infinite.
Nope.
Oh.
Anybody else have any ideas? What numbers are? And there's one particular number that we're kind of talking about here. Would we consider to be undefined? There's square roots of negative numbers. That's a good one. And then what's the other one?
The ones that don't end and don't repeat. I'm not sure.
Nope, those are okay. That's like 1/3 and, things
Yeah.
like that. That's okay. Is there something that we can't divide by? Right, this is a division problem, right? Is there something that we can't divide by?
Yeah, you can't divide by 0. I know
Divide
that.
by 0, yeah. Okay, so that's the big one that we're going to be looking at there. What happened there? So we can't divide by 0. And so if I look at this function, where's my tools go? I lost my chat box somehow. I'm not sure where it went. If I look at this function right here, right? So when x is negative 1/2, what happens? Well, I get on the bottom, I get 4 times negative 1/2 plus 2, right? And it would be 1 over that, right? So what's 4 times negative 1/2? Well, 4 times negative 1/2 is negative 2 plus 2. And so I get 1 over 0. All right. So when x is negative 1/2, my function turns into 1 divided by 0, which is undefined. And so that's what happens right here at negative 1/2, right? If I put a line here, oops. If I say, show me, x equals negative 1/2, right? At this line right here, right, that function is undefined. So that function doesn't exist right there. And so I can look down here, it looks like it gets really close to that line, but it never quite actually hits that line. And that's why, is because when I put negative 1/2 into that function, the y value becomes undefined.
I have a question.
Yeah.
Could we also type in negative 0.5?
Yeah. Let's
Okay.
try that. Negative 0.5. Right? Also undefined, because that gives you the same thing, right? 4 times negative 0.5 gives you negative 2, and then you add 2 to that, and that gets you to 0 again. So,
Okay.
all right. So when you look at problems like this, what they're really asking you for is they're asking you, like, where would that denominator be equal to 0? So in this problem right here, where I have 1 over 2x plus 8, what I would be looking for is I would say, well, I know that that 2x plus 8 can't be 0. Okay, so 2x plus 8 can't be 0. That means that 2x can't be negative 8, which means that x cannot be negative 4. Because if I put negative 4 into this function, I would get 1 divided by 0, which would be undefined. So this number right here would be negative 4.
Okay.
All right. So that's one of the things, especially when we have functions where we're dividing by a variable, we always got to watch out for that, right? And likewise, if we have a function where we're taking the square root of a variable, right, we know that that square root can't be a negative number. And so, you know, we're going to look at those as well.
I have a question.
Yeah.
I noticed you're recording this.
It just records automatically. I can upload that if you want.
Yes, please, and thank you.
Yeah, I can do that. Any other questions? That was a good problem, Seth. Thanks for asking about that one.
You're quite welcome.
Any other problems in 5.1 or 5.2? Right, so in 5.2, they start talking about function notation, right, and what that looks like, what that means. So we start talking about using f of x instead of y. So we start seeing that notation show up. 5.3, they're going to kind of expand upon that. In assignment 5.3, they're going to talk more about function notation, right, and what that means, and how to write that and so forth. So the big thing to kind of keep in mind here is, right, that f is the name of the function. And in this case, that function is called f. And this variable inside here is the input. So that means I put z, values for z, into that function. The z's are my input, and my f of z is my output, or my y value. Okay, so this says to write a function, right, the total cost, and z is the price of gasoline. So z is going to be my input. And so if I want to figure out the cost, I would take the number of gallons, I would multiply it by 3. And so my function would just be 3z. And so this f of x here represents the cost, or that f of z actually represents the cost. So they ask you to write some different functions here. On all these, x is the input, and then we're going to do something to x to get the output. And so this tells you what to do to x. You're going to multiply the input x by 4 and then add 6. So this is going to be 4x plus 6. I'm going to add 6 to the input and then multiply it by 4. So I'm going to go x plus 6. And then I'm going to multiply that whole thing by 4. And so we're just trying to like keep in mind what's the input and what's the output. So the input is always that variable, that f, that x, and then the output is always the value of the function. So in this problem, they give you a function, right? This function is a function of p, which means that p is my input. So p is the population, p is my input, and then it outputs g, which is the garbage. So, so g is the output, p is the input, and the function is what happens there. And so when they want to say that the population is 50,000, okay, that's my input. So my input is 50,000. So this one here is going to be 50,000 is going to be my input, and then my output is 10 tons of garbage. So that's going to be 10. So input and output. And then they ask you about some graphical ways to do that. So here they want you to find the value of that function when the input is -2. So what I'm going to do is I'm going to go over here and look at where x is equal to 2, where the input is -2 right here. And I'm going to go up here and look up and see, oh, here's the output right here, right? The output here is 3. So when x is -2, my y value or my output of that function is +3. So this is a similar one. They want to know when the input is +2, what's the output? So I'm going to go over here to 2 on the x-axis and then look up to where it hits the graph, come over here and say, well, 4 is going to be my output. So f of 2, we would say is 4. This one is slightly different. Here they tell you the output. The output is 4, and they want to know what the input is. So on this one, I'm going to look up the output of 4. I'm going to come over here to where it hits the graph and then look down and see what my input was. The input was -2. So here I would choose -2. So it's just looking up inputs and outputs. Here's 4 on my output, and that leads me over here to -2 on my input. You have some problems in here where they give you a function and they just ask you to calculate values. So, you know, if you want, you can plug in -2 and calculate those. What I would probably do is I would just probably use a graphing calculator on this, right? Just use a calculator and look up those values. So if I had 3x squared minus 2x plus 6, and let's see here. So here I can see my function, and then I would just turn that into a table of values and look up those values. So I would turn that into a table of values, and I would just look up those values. So here it tells me f of -2 is 22, f of -1 is 11, f of 0 is 6, and so forth down the line. And if the value that I was looking for wasn't on here, I can just add it. I can just type it in there. And they're asking you to evaluate functions. You can decide, you know, the best way to do that. If you can just, you know, write it out and do that math, that's probably pretty quick. If I had to do 4 or 5 of them, I would probably use a table of values. You should be able to do it either way. So here's another one. I would use a table of values on this. I would type in this function, make a table of values out of it. Same thing here. These values I'd probably have to type in. this problem, they're asking you two things. They're asking you to look up where the input is 4. So I go here to 4 on my x values, my input, and hit the graph, come over here and see that that y value is 2. Second part asks for the opposite of that. They want to know where the output is 4. So I'm going to come up here on my y values, right, and look at 4, and then go over to my graph and see where that input is. And at this point it's -3. Just giving you information in different formats. Sometimes they give it to you as a graph. Sometimes they give it to you as an equation. Sometimes they give you the function as a they give you that function as a table of values. So in this case, the input is 1. So I'm going to come over here to the input of 1 and look up the output. The output is 16. So I put 16 in here. Here they tell you that the output is 5. And they want to know the input. So I'm going to look at the output is 5. That tells me that the input has to be 4. I'll just post this video just on the main page there under the videos. So. Question number 14, they give you kind of a weird function here. This is a function, but it's actually a function that's made up of 2 pieces. And so when you go to look at this function, you have to look at the inputs. So this function says that when x is less than 0, this is going to be my output here, 2x plus 3. And when x is greater than or equal to 0, then my output is going to be 2x plus 6. And so right here, where I have f of -1, well, -1 is less than 0, so I would use this part of the function to calculate that. And for the other ones, where x is 0 and x is 2, that's going to be the second part of the function. So this is what's called a piecewise function. We'll talk more about piecewise functions in Algebra 2. And the last part of this, they're going to give you some functions, and then they're going to ask you for the domains of these. Okay, so we talked about a problem similar to this earlier, right? Where they said, well, where are the values that don't exist on this? And so if I were to look at this this function here, let me go back to Desmos. Whoops. Go back to Desmos and I put in this function. I have f of x equal to, let's say I need the square root. Keyboard here and get the square root. So the square root of x plus 5. So I can see what that graph looks like. And I can see that that graph ends right here at -5. So it doesn't go past that point. This side, it seems to go on forever. Okay. So it looks like this graph starts at -5 and goes on forever, right? So the lowest value, right, the domain, the input of this, the lowest value here is -5. And the biggest value is infinity. So in interval notation, I would say this is interval notation. It goes from -5 to positive infinity. So from -5 to positive infinity. It can equal -5, so I'm going to use a square bracket. And then I've got the infinity here, so we always use a round bracket on infinity. Now, you might ask, why does that graph end right there? Well, if I look at a table of values of this graph, right, if I look at -5, I get 0. But if I put in, say, like -6, I can see that's undefined. And so you think, well, why would that be undefined when it's -6? Well, if I put -6 into this function, I would get the square root of -1, which doesn't exist. It's not a real number.
Okay.
So that's why it's undefined.
Okay. All right, I remembered my question.
Yeah, go ahead.
How many questions are there on 5-3?
20?
Okay, thank you.
Yep. This problem is asking for a similar thing, right? What's the domain of this? Again, I would just graph each one of those functions and kind of see where it starts and ends. And so, for example, if I look at this one, I don't know if I can copy and paste this or not. 6x plus 8. Six x plus 8. It didn't say anything. So x. So if I look at this graph, I can see that it starts down here. And so if I look at the end of that, negative 13 and a half, maybe. It's kind of hard to tell based on that. I'm not sure why it's not showing me the end of that. Like -1 1/3. But really what I care about here is that this thing, right, this 6x plus 8 has to be bigger than 0, right? So I can look and try to solve that. This 6x plus 8 has to be bigger than 0. So take a look at those. Watch the video on those two. They'll give you some other hints of how to go through those problems. But if I look at that and I say, well, 6x plus 8 has to be bigger than 0. 6x plus 8 has to be greater than or equal to 0, then I can go ahead and solve that. So I know that 6x would have to be bigger than or equal to -8. And so that x would have to be greater than or equal to -8 over 6, which would be -4 over 3. So that's that -1 1/3 that we saw on the graph. Right, so I can see at -2, it's undefined. If I look at -4/3, I can see that that's -18. But if I look at something bigger than that, say, or smaller than that, say like -5/3, that's undefined. So -1 1/3 is the smallest that it can be. Okay, so these are a little more challenging at the end. So again, they're gonna, this 3x minus 47 has to be bigger than 0. 12 minus 4x has to be bigger than 0. And then this is similar to the other one we were looking at, right? What's the value that's not in here? Well, 6x plus 2 can't be equal to 0, right? Because that would make that undefined. Okay, so the last ones here are a little more challenging. So again, watch the videos on those. Take a look at the graphs, right? Graph them and see if you can kind of make sense of what that means there. They're always looking for the domain. So they're looking for the x values. What are the x values that will make that work out? So. So there's a lot to kind of go through. And like I said, I'll post this recording on the main page there. Any questions about any of the assignments? 5.1, 5.2, any of the stuff on 5.3? Our big ideas here, right, are understanding what a function is, understanding what function notation means, and then being able to read and understand, sets of numbers. So when we talk about the domain, right, what are the set of numbers that are part of that? If there are no other questions, I'm going to go ahead and just let you guys work and just holler if you have any questions. Okay.